Hi, this is Reddy from Narayana Techno. So today's our topic is writing the sum of examples using the functions mechanism. So now the first example is write a function to return the factorial value of the number. So we are asking to be write a function that is to be returning the factorial value of the number. So that is nothing but what is the category we have to be select to write this function is. So that is input we have to be passed to this function to be written the factorial value of the number. That is nothing but so we have to pass one argument to the function, that is to which number factorial has to be calculated. So that is nothing but function with the argument, and we are asking to be written the factorial value is nothing but what is the category to be select to write this function is function with the argument and as well as written value. So now if we let's observe this program is so as include std avoided h. Return type of this function is called int or long int, whatever you want to be written that factorial value. That is the name of the function is called fact, and through this function we are going to passing that is an integer value. So that is nothing but a function with the argument and as well as written value. So then void main, that is int n, that is nothing but first we are writing the main function, then we'll define that function here. So int n comma f. So enter the any number, scanf percentage number. Then we are calling this function. Earlier we written this function for functionality using the while loop mechanism. So previous we used to write this functionality here itself only, that is within the main function itself only. So that is while n greater than 0, then f equivalent to f multiplication n minus minus. That functionality we used to write in this function main function itself only. Now we are going to writing in separate function. That function we are going to calling this one. What is that function name is called as factory. So what is the advantage of the functions that we already explained, that is a reusability mechanism. So reusability is nothing but once the function has been defined, that function can be called wherever it is required without rewriting that function the definition statements or instructions. So that is n number of times we can call it here, so that you can able to save the time and as well as space here. So that is advantage with functions mechanism. So if you want to be write within the main function itself that functionality, if it is required more times, then you should write more times so that it's unnecessarily wasting of the time and space. But using the functions mechanism, write function definition once and you can call n number of times. That is advantage with the functions mechanism. So now we are calling this function, that is fact of n. What is n value? Right now we are assuming as, let us for example 5. Whenever you call this function, the control is going to pass into the function definition. What is the function definition? Into fact of into x. What is n value? Right now we are assuming as 5. That is copied into x. So what is x value? Now it is 5 here. Then into y equivalent to 1 here. So already we written this logic earlier. That is a factorial 0 is 1. So that is while x greater than 0. What is x value? Right now it is called as 5. 5 greater than 0. Then y equivalent to y multiplication x. What is y value? Right now 1. 1 multiplication x is right now 5. That is nothing but y equivalent to 5. Then x minus minus. What is x minus minus? It is 4. We already know that multiplication of all the values from n to 1 is called as factorial value of the number. Right now it is x value is 5. Sorry, 4. 4 greater than 0. Y equivalent already 5 into 4. That is 20. X minus minus 3. 3 greater than 0. Already y equivalent 20. 20 multiplication is called 60. X minus minus 2. So 2 greater than 0. Already 60. 60 into 2, that is nothing but 120. X minus minus 1. 1 greater than 0. Again y equivalent to 120 multiplication 1. That is 120. X minus minus is 0. 0 greater than 0. Condition is false. Come out from this loop. After come out from this loop, what is the value of y here? That is called as 120. Whatever this 120 value is there, that is returning to the caller. That caller is stored into some variable name is called as f. What is f value? Right now it is 120. So what is this 120? Is a factorial value of n. What is n value here? That is we are printing. What is the output here? The percentage factorial is percentage n comma f. What is the n value here? 5. The 5 factorial is percentage f. What is f value here? That is 120. So that is 5 factorial is 120. So this is an output of this function. So that you can call n number of times. So that is once the function has been defined, that you can call n number of times. Next time you can call this function with the fact of n1, fact of n2, like that you can call n number of times. That is advantage with the functions mechanism. Now our next example is called write a function to be written the sum of digits of the number. Again, if you observe this one, here also we have to be write this function with the category is called So the function we are asking to write to be calculating or returning the sum of digits of the number. So that is nothing but the function category is function with argument and return value. So we need to pass an input is that is to which number sum of the digits are required to be calculated and returning the sum of digits of that number here. So function with the argument and return value. This is a fourth category when we explain that is in the types of categories here. So now if you let's observe this program here as include std average long int sum of digits then long int. You can take int or long int, that is your case here. So then coming to the main function long int n comma sum. What is n here? That is input. Sum is nothing but sum of digits of the number. Enter any number. Percentile LD then number. Sum equivalent to sum of digits of n. What is n value right now? We are assuming that 3, 4, 5, 6. Let's for example 3, 4, 5, 6. Whatever we call this function, that is copied into the function definition of formal parameter, that is nothing but sum of digits of x. What is x value right now? N. N nothing but right now we are assuming as 3, 4, 5, 6. X is 3, 4, 5, 6. Long int r comma s equivalent to 0. R is for remainder and s is for sum here. While x greater than 0. What is x value right now? 3, 4, 5, 6. 3, 4, 5, 6 greater than 0. R equivalent to 3, 4, 5, 6 modulus 10. This logic already we explained the while loop mechanism. We written this examples in while loop mechanism. That same logic we are repeating here. So what is x right now? 3, 4, 5, 6 modulus 10. So what is 6? That is adding to s. S is nothing but now 6. Then x divides 10. 3, 4, 5, 6 divides 10. 3, 4, 5. 3, 4, 5 greater than 0. So r equivalent to 3, 4, 5 modulus 10. Nothing but 5. Already s is 6. 6 plus 5, 11. X divides 10. 3, 4, 5 divides 10. Nothing but 34. 34 greater than 0. R equivalent 34 modulus 10, 4. Already s is 11 plus remainder is 4, 15. X divides 10. That is what 34 divides by 10. That is nothing but 3. 3 greater than 0. R equivalent to already x nothing but 3 modulus 10. 3 modulus 10 is nothing but right now 3. Already s is now 15. 15 plus remainder right now it is 3. X nothing but 3 divides 10. 3 divides 10 is 0. 0 greater than 0 condition for come out from loop. What is s value up to now? That is first time remainder is 6. Next remainder is 5. Next remainder is 4. Next remainder is 3. So there is nothing but so 3 plus 4 plus 5 plus 6. That is nothing but 18 here. So if the number is input number is 3, 4, 5, 6, then sum of digits is added and stored into sum of the reminders. Nothing but sum of the reminders of the given number. Sum of the digits. So that is stored in s. That s is written here. Whatever s, what is s right now here? Sum of the digits of the given number here. So that is stored in s. That s value is written to the caller and has been stored into the sum variable. What is sum right now here? 18. So that is what is the 18 sum of digits of the 3, 4, 5, 6 number. So 3 plus 4 plus 5 plus 6 here. So that is 18 here. 3 plus 4 plus 5 plus 6 here. So that is 18 that we are printing it. So the printf, the sum of digits of the percentile LD, sum of digits is percentile LD n comma. That's what is n here. The 3, 4, 5, 6 sum of digits is percentile LD. What is percentile LD? Is nothing but here sum here. So that is going to printing, that is 18. So the 3, 4, 5, 6 sum of digits is 18. Like this, you can enter any input here. Based on your input, it is going to calculating sum of digits of the given number, and that is returned to the caller, and caller has been stored into some variable that is going to printing the output here. So this is a category of the example is function with the argument mechanism and as well as return values here. So in the next video, we'll be going to come up with some more examples to be writing using this function categories mechanism. So users, if you like this video, please like and share, and for more updated videos, please subscribe our channel. Thank you one and all.